All right, segment MN, which is shown in our graph here, has endpoints at 3, 2 for M and 5, 6 for N. Use the midpoint theorem to find the midpoint of segment MN. Now, this point here looks like it may be the midpoint, but they wanted us to use the midpoint formula to find out exactly where the midpoint is. The formula for the midpoint between 2 points in a plane, we've done before, but as a refresher, you add the x values. So you do x1 plus x2 divided by 2. That gives you the first coordinate of your point. The second coordinate is your y values. So you add the y from your first point and the y from your second point and divide by 2. So again, these x1s and x2s just means the x from your first point, the y from your first point, the x from your second point, and the y from your second point. So when you do the midpoint, again, you're finding a point. So it's going to be a number, comma, a number, your x value here, your y value here. We add our x's. So 3 was the x value from the first point, plus 5, the x value from the second point, divided by 2. 2, the y value from our first point, plus 6, the y value from our second point, divide by 2. 3 plus 5 is 8 over 2. 6 plus 2 is 8 over 2. 8 divided by 2 is 4. 8 divided by 2 is 4. So we happen to come up with the point 4, 4. Is it the way it looked on our graph? Yeah, 1, 2, 3, 4 to the right, and up 1, 2, 3, 4. It is at the point 4, 4. You want to double check using algebra. Find the slope of the perpendicular bisector of MN. Now we may be able to look at this line that appears to be the perpendicular bisector and find it that way. But we need to go the correct route and first use the formula for slope to find the slope. Now remember, slope is the change in our y values, or our rise, over our run, the change in our x values. So on top we subtract the y values from our points. So 6 minus 2, those were our y's, over 5, that's our first x value, minus 3. 6 minus 2 is 4. 5 minus 3 is 2. And 4 divided by 2 is 2, or 2 over 1. So the slope of our original line, okay, so this is not the one perpendicular to it. The slope of our original line was 2. We want the slope of the perpendicular bisector. The key there being perpendicular. So we think about perpendicular lines and what we know about their slope. Their slopes are opposite reciprocals. So we take the number 2 here and make it opposite. So instead of positive, it will be negative. And the reciprocal of 2, or 2 over 1, we flip that fraction and it would be 1/2. So the slope of a line perpendicular to MN would be -1/2. MN had a slope of 2. Our perpendicular line would have a slope of -1/2.